So now we're going to start off with a quick demonstration of this circuit. I get it dark enough that bright LED turns on, and it's a 5-volt LED module right there. It's letting through, you know, somewhere around about 200 milliamps of current, and instead of turning the lamp off, I can just cover the light dependent resistor right here, because that's the main component that determines whether that LED turns on. It tells the 555 timer whether to have a high or a low output signal, and that high or low output signal, high, makes the relay switch right there. A low signal makes it so that the relay stays basically in the off position. So now we're going to ignore the LED for a moment, the LED module right there, and look at the 555. So I'm using an NE 555. If you have a micro A, it should work the same, but there's other variants where it might work a little bit differently. So make sure you check the dash sheet. But in any case, there's the pin layouts there. Top left pin is 1, work your way down to 4, jump across 5 up to 8. So, you know, just kind of a quick review. But in any case, we have this wired as an inverter. So pin 2 and pin 6 are together. They're both looking at the same voltage. Pin 6 is waiting for 2/3 or higher voltage. Pin 2 is waiting for 1/3 or less of the supply voltage to tell the output what to do. And in the middle ground region, it's going to stay in whatever place we last put it into. So pin 6 right there is waiting until the voltage gets up to 2/3 or higher voltage. So that's when it gets bright enough on the LED. You can see on the light dependent resistor right there, LDR, not LED. So in any case, it gets bright enough. That pulls it up close to 5 volts, you know, more than 2/3 of the way at least, and then the output is low. It goes low, connects to ground pretty well right there. Our relay is going to respond to a high input. I could rewire it to respond to a low input with this particular relay, but we're going to just look at it when it's high. It would switch the opposite if I switch whether it's active high or active low. So in any case, we get enough light, that's a high input, that equals a high output. And when we get dark enough, it's almost like this light dependent resistor doesn't exist. You can see that's going to the negative supply. That pulls the voltage down. Pin 2 is waiting for 1/3 or less of the supply voltage. Drops below 1/3, and the output goes high right there. Pin 4 is connected to the positive supply. That disables it. If pin 4 sees a ground connection right there, it's going to hold the output low no matter what. We don't want it to do anything, so we go to the positive supply, and then it doesn't do anything. So, review. Get a high enough voltage, output goes low. Get a low enough voltage, then the output goes high. So, we got an inverter right there. And before I forget, I'm using a 10,000 ohm resistor on the low side right there. That seems to be a good balance when it comes to this lamp that I'm using, whether it's on or off mainly. But in any case, we could adjust the sensitivity. Use a lower value resistor right there. It's going to hold the voltage down. So you'll have to get it even brighter for the light dependent resistor to give a high input. You use a higher value resistor right there. It's going to be easier for a high input right there. So you can adjust that, but 10K usually works out pretty well. So now we'll look at this part of the relay module right there. So it pretty much counts for this area right there. That's a mechanical switch. It's moved though by the magnetic field created over here, but there's no actual electrical contact between the two, just a magnetic. But in any case, I have this jumper to the H there, so it's a high. When we don't have a high input, this is just in its resting position. That's normally open, it's not connected. We give a high input, it will switch, as we saw before. If we move the jumper instead, then a low signal will switch it, and then when it's high it will not switch it. So we could adjust that, but we have it active high right now. High input switches it, so we have to power it, of course. So there, I believe it says V plus, I could be wrong. V minus right there. Those are the power pins for the module right there. This can be a completely different power source than whatever is powering the load. As I said, that's just a mechanical switch moving back and forth, but we're using the same power source in this video. And then we have our signal, which says in right there. And so that's our input. So that's what we're receiving the signal from, I should say. So our signal is coming from the output of the 555 timer, which is pin 3. So yeah, I can wire this up right now, pretty straightforward. We have to power this, and we can just do that. We should have no problems as long as they don't short circuit. any connections right there. So yeah, we got it powered. And then this goes to pin 3. Pretty straightforward. I have the power supply off too, so I don't have to worry about short circuits. So now I'm going to turn the power supply on, and I don't think I can darken it with my finger enough, but with the jumper there, if I get it dark enough, you should be able to hear that click. So now moving over here, our load is this LED module right there. So I got like 20 of these for I think like $10 or something. They weren't terribly expensive. Before I cleaned up my soldering iron tip, got a new one actually. There's pads right there. I took the wire and then put a big glob of solder on there to hold them together. So I actually had to wire this up, and you have to break these off of each other. But yeah, there's a resistor already on there, and the LED, and a heat sink on the back. And so I'm not sure, that's probably connected to ground or something, I don't know. So probably don't want that to touch any of the circuitry. But any case, we will just plug it in there. So we are going to the positive supply. On the positive side of that, there's a plus and minus to indicate which one's which before you solder. So in any case, yeah, that's all built onto the board. 5 volts, and so I used a 5-volt relay there. Again, we don't have to. We could have used 12 volts if this was a 12-volt relay for all that circuitry, and then, you know, a separate 5 volts for this if we wanted to. Now, before you hear a click when there's no input signal or power is not applied or anything altogether, it automatically makes a connection to the NC spot. That's the common right there. We'll look at that in a bit. So it's connected to that. We're not connecting anything to the common. So you can see that, or to the NC right there, normally closed. So these two are already connected together. If I had this going to a circuitry that was powered, it would be on right now. But instead, we're to the normally open spot right there. So it's not connected even when power is applied until you get that high input. Then it moves mechanically over there. But again, it's just magnetic fields moving that over there. It's not electrically connected. None of this electricity is making it over to this electricity unless you got such a high voltage that you fried something, you know. So okay, so I got blue on both of here. So COM doesn't really matter too much with this setup because we're only doing one side. And I'm kind of aiming through the camera, so that's why my view is way off. But in case, yeah, we got COM there, and then this is our normally open spot right there. And we will plug it in. So I still have power applied. There's a bunch of metal on the bottom, so I don't want that to touch any metal right there. So I don't know where I stuck that bag. I got resistor bag over there though. But in case, yeah, we'll move that over. And now we should get, yeah, power still on. And by the way, there's a little green LED down here. So I think that's what that current is. Mostly that green LED. There may be a little bit of other stuff that is using up some current too. So yeah, this is not something you want to leave connected to a battery for long periods of time unattended. But there will always be a little bit of current going. But yeah, there you can see. Now it's on, and we got, you know, somewhere around about 229 milliamps of current. Let's unplug this. That's pretty much it. Let's unplug this, see how far that goes. See, we still got about 3 milliamps of current. But I can just yank this out and connect it directly to the power supply right there. And yeah, we got even more current right now, which is kind of interesting. Probably because these jumpers are not making the best connection. So it's not conducting as well as it could. And these get really hot if they've been lit for a while. It's kind of warm now, but it's not too hot now. So yeah, these jumpers, yeah, they're terrible. Connection probably at this point, probably not so bad over there. And so, oh yeah, that's right, I got to get it darker, turn it on. For some reason I was expecting the light to come on. Oh, I unplugged the module, that's right. So yeah, I purposely did all that, but kind of forgot about it. So it's kind of a blooper there, but that's one of the things with electronics. You kind of unplug stuff, you forget about it, and then you wonder why stuff doesn't work. You kind of got to track all the connections right there if it's not working. And maybe you move something on purpose just temporarily or something, or just forgot that you did, and so you just got to reconnect it. That's one of the troubleshooting tips that I have. So yeah, that is about it. So again, just a quick review. This went on long enough, but maybe you forgot what this was all about. We have a light dependent resistor right there. High when it's bright, like it is now, low when it is not. But the 555 timer, the way we have the two inputs, when you get a high enough voltage, the output goes low when you connect them together. When you got a low enough input, the output goes high, as close to 5 volts as it can. Low is as close to 0 volts as it can. And so the output's going to be the opposite of what the input is. We have this wired to be active high. And yeah, we can do that right now. Even though on the schematic, I just showed it as active high. I was thinking of just making a different video where I just cover the relay, but for now, I'll do this. There we go. So I moved that jumper for some reason. These pins, they're either spaced like a little bit farther apart or a little closer apart than those two. It's harder to get into there. But yeah, now we're active low. So with this particular relay, not all relays you can adjust it. Some of them come active high, some of them come active low. There's other variations of relay. But yeah, now we got it on when it's bright enough, if that's what you desire. You know, it's all about what you need, you desire, not what the schematic you come across tells you to wire up. The schematic is just a starting point right there for helping you figure out stuff that you're not already aware of. After that, you can modify it as needed to suit your needs. So, in any case, we have a lot of stuff wired up here. I am going to pluck it all, and so that we don't have as much connected, and turn the power supply off. Usually, another thing I'll do, even though this is running on way too long, usually I just like light LEDs and stuff. The relay needs more than so there's like an endless number of things that you can explain. So we don't have to worry about the 5.5 time circuit. We are just gonna go to that's right, I put it to active low. Active low, I don't have enough current. That's right. So yeah, it takes about 70, close to 70. We do have a little bit of other current going elsewhere, so slightly below this, just to energize the coil. That's a very important thing to realize. It's not just the signal is moving it and you're not using up energy. When you are in the normal position, so now the coil is not energized, no current's going through the coil, we just got that LED probably mostly, and then a little bit of what that circuit's doing. But the coil does need a significant amount of current right there, probably somewhere around about 65 milliamps of current. If you are using a 12 volt module, this is a 5 volt module, so we got to use 12 volts. We can, or 5 volts. We can switch a lot more voltage though. You have to look at the limits on the module. So yeah, I think we're all done with that now. And so I'm not going to look through the camera, so you probably won't be able to see this too well. It's kind of hard to see in person. But yeah, 10 amps, 15 amps in some cases, but it can switch up to 10 amps. I'd probably leave it like 5 amps. Plus these aren't very big, so you're kind of limited with the size wire you put in. But yeah, it's made for up to 250 volts. It says, that's dangerous to work with though. 125 volts. You could switch it if you want. A lot of times they show a DC voltage for switching, but I do not see that right now. So all I see is AC voltage. Usually it's lower, so I'm guessing maybe like 30 volts. I think that's pretty common, 30 volts. I could be wrong. But another thing, so it just says 5 volts DC up there. Down here, I think it should say, usually they say like 5 down here, but you might have to like look up that part number. If you need more information right there, you should be able to see it right there. A lot of times in the part number it has like 5 if it's a 5 volt for switching it, or 12 for 12 volt switching it. So that 5 volts is for this side here. Only work with 5 volts over here. You can use much higher voltage over here. This doesn't really rely on current, although as you saw we need like 65 milliamps when the coil is energized, and then we got that LED and stuff. It uses a little bit of current and stuff, but this is where like the switching large amounts of currents in the amp range occurs right there if you want to. And we just did like 200 milliamps here. Very easy for this module. These jumpers, probably don't want to go a ton higher. I think like 500 milliamps max for those jumpers. I'd want bigger wire if I was like going in the amp range. You know, I might push like 1 amp, but just briefly. With these, I try to stay like half of an amp. I got bigger wires and stuff. Again, this video went on plenty long, but there's all kinds of stuff I could mention about this. So, but I kind of ran out of them now, so good time to end it here. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.